Hi guys, Mr. Sonnenberg here. Today we're going to talk about pure substances and mixtures, and we'll do compare and contrast the two. Well, not necessarily. We'll just talk about the differences between the two, but we'll talk about how pure substances, though different from mixtures, can actually be a part of mixtures. So, excuse me. Anyways, pure substances. They're made up of one type of particle. That's the main thing. They're made up of one type of particle. So, for example, distilled water, it's made up of this stuff called H2O. So there's 2 parts hydrogen, 1 part oxygen. In a cup of this H2O, okay, we have a cup. All the particles inside this glass of water are all H2O. Important to remember. Okay, so all parts are identical. Now, it also has a definite formula. So say we're doing table salt, well, it's sodium chloride, it's all sodium chloride. Okay, it's all that compound. It's all H2O, it's all sugar. Okay, so depending on what type of sugar it is as well. Okay, so then we talk about mixture. So pure substances, remember, one type of particle, all parts of the pure substance are identical. Okay, and there's some examples. Now we talk about mixtures on the other hand. They contain more than one type of particle. So if you take a look at the image down below, down here, well, that is what we would call a mechanical mixture. Now in a mechanical mixture, you can see all the different components. For example, peanut butter. Okay, you can see all the different types of, or not all of them, but you can see different types. So you can see the nuts in it. Like say it's peanut butter with nuts. Well, you can see the nuts within the peanut butter. Or if it's orange juice, like this over here with pulp, you can see all the different components of it because, or not all, sorry, I keep saying all, but you can see that there is pulp and it's separate and you can actually sift through. If I was to put it through a colander or something, then what would happen is the pulp would remain, the juice would flow through. Okay, but they don't have a definite formula because it's a series of formulas put together. Okay, so these mixtures, well, no, it's not because it has that um, different formula. But if you look up top, we have concrete. There's aggregate within the concrete, so there's gravel, there's water mixed, and then cement powder all mixed together, and it forms concrete. And then when it solidifies or it hardens, it solidifies. It makes this pads, or it can make foundations for buildings. It can make pilings to support the floor. It can make slabs. It can also make your walls as well. So some substances you need a microscope to see the different types of mixtures of, because not all mixtures are mechanical mixtures where you can see the different components. Some of them you can't. Examples of that might be milk, which is a colloid mixture, or then there's suspension mixtures, which are also a little different. But some things you can't see, like bleach and motor oil. Okay, things like that you might not be able to see, but they're actually mixtures. So things mixed together. They're not all the same substance. They actually contain more than one type of particle. So you'd have to take a microscope to look at those ones. Okay. So moving on, what is the difference between a pure substance and a mixture? So we know that pure substances, there's only one type of substance. Mixtures, there's more than one. But in order to tell substances apart, though, you would have to examine more of the properties than just a few basics that we've talked about. You might be able to tell them apart by their smell, their texture, their density. You might need to examine their chemical properties, or you might even have to investigate their boiling points and their freezing points. And we're talking about all these properties. This actually is going to lead into the next screencast, which is going to be chemical and physical properties, so you can identify the two differences. But then, if mixtures boil and freeze at different temperatures, well, we need to understand that they do boil and freeze at different temperatures than the pure substances that make them up. So the key here, though, is we have to understand that pure substances make up mixtures. Okay, and then we understand different type of mixtures. So if I ask you questions about, excuse me, what a mechanical mixture was, well, I would be able to explain right now that why do I keep hiccuping? Well, it's because I just ate a mechanical mixture. I had ice cream and I had apple crisp. So in the apple crisp, I could see the granola, I could see the apples, I could see the crust, and then I could see the ice cream. I could see all the different components, and I ate it. That's a mechanical mixture. But then I'm trying to wash it down with water, which is a pure substance. But inside that mechanical mixture, well, I know that there's things like sugar. There's probably a little bit of salt, maybe. Okay, those things that are in there might be pure substances, but then they make up mixtures. So all these mixtures are actually a combination of a series of pure substances that make them up. But like I said, that apple crisp I ate, which was delicious, and I don't have enough to share with you guys. And by the time you guys get to this, it'll probably be bad anyways. So, or I've ate it already. But so anyways, the apple crisp was a mechanical mixture. Okay, and washing it down with a pure substance, which is water. Okay, moving on. How do we use mixtures? So how do we use these mixtures, and how do we understand that some of their properties, so boiling and freezing properties of these mixtures, how can we use these in society? Well, we live in Alberta and in Canada, so therefore we get a ton of snow. And with the snow comes melting and then freezing. And with that comes the concept that our roads are going to be icy. And so what's going to happen is slip and slide, they become dangerous. So what our road crews do is they use those properties of mixtures, and we keep the ice off the roads. They do this by adding salt, okay, or sodium chloride to the snow and the ice on the roads. And that actually creates a saltwater mixture, and it doesn't freeze in the typical winter temperatures. Now, we could typically use, say, salt water alone in certain types of the winter, but we'll use it in those certain types, or certain, I guess, parts of the winter. But sometimes it gets so cold here that we have to add something else. So sometimes we add calcium chloride to the sodium chloride, and that's when temperatures are too low. And then that saltwater mixture, it's going to keep that ice from freezing to the road or creating ice. It's going to keep it thawed so that our roads stay dry, so we have traction. But sometimes, so say in Toronto, they would probably rarely ever have to. They could just use salt and water and create a saltwater mixture that keeps the roads ice off the roads. But here in Alberta, because it gets so cold so frequently, we add a little calcium chloride, and sometimes that's going to decrease the freezing point at which the temperature or the ice is going to melt. So, or that solution is going to melt. So that way we can keep the roads dry, or not dry. Sorry, they're still wet, but we'll keep the roads, the ice off the roads, even at lower temperatures. So anyways, that's pure substances and mixtures. It's just a breeze through. We actually touch base with it a little bit more when we talk about solubility as well. So hopefully this has helped, and the next, or hopefully that we see a connection between the next screencast, which is going to be properties of physical properties and chemical properties. All right, hopefully this helps. See you on the next one. Bye.